Hello students, welcome to your channel Sukh EduWorld. In this video, I will try to cover next 15 questions from 41 to 55. Okay, so let's start. In this 41st question, they are saying the final product obtained in this reaction. So they are giving you Grignard reagent and one, this is alpha beta unsaturated aldehydes. Okay, so what will happen? The general molecular formula of Grignard reagent is RMGX. So this is your Grignard reagent. Clear? Clear? So Grignard reagent, it will break as R negative, MgX positive, and this R negative will act as a nucleophile. This is very simple reaction. This is nucleophile. What will happen? First of all, to increase the electrophilicity of carbon atom, this carbonyl carbon. Okay, so first of all, this MgX will act as a electrophile. Okay, and will get lone pair of oxygen, due to which oxygen will get positive charge. Okay, now this carbon is very electron deficient, right? And this R negative of Grignard reagent will attack onto this carbon and these electrons will shift here. I'm showing you general mechanism, right? And accordingly you can proceed this reaction and you can reach to your product, and these electrons will shift here. This is H and this is your R negative. Clear? And at the end there is hydrolysis in the final product, and from the water you will get H positive and OH negative, and OH negative will attach with this electrophile magnesium. Okay, and this will be your as a byproduct, and there is electrophilic substitution reaction and MgX will replaced by H positive. Okay, and there will be OH, H and R. Clear? And this will be your final product. Now R group. So R is your nucleophile and it is generated from RMGX. So in this case your R negative is this. This is your R negative and this is MgX positive. X is any halogen like chlorine, bromine. Okay, RMGX. So you can attach this nucleophile in the place of R and you will get final product, and this final product will be this third option. Okay, so third option is your correct answer in this question. Okay, in the next question, what is the structure of first singlet excited state? First singlet excited state of formaldehyde. So what is the formula? Structure of formaldehyde, this is right. And you can see in this case oxygen has non-bonding electrons, right? And there is pi bond. So in the first excited state, what will happen here? There will be a transition of non-bonding electrons of oxygen to pi star. Okay, because there is pi bond, so there is a pi star anti-bonding. Okay, so as there will be a movement of non-bonding electrons to pi star orbital, what will happen? The carbon, this carbon atom, you know, before excitation its hybridization is sp2, but after this transition its hybridization will change into sp3. Okay, so overall now its structure will not be a planar, it will be a slightly tilted and pyramidal. Okay, so first option is incorrect. Okay, the correct option is pyramidal. You will tick this option, okay, due to its. So fourth option is correct answer in this question. In the next question, the energy of particle in one-dimensional box can only take discrete values and is quantized. The energy value is directly proportional to quantum number. So in one-dimensional box, if you read, in that energy of the energy is equal to n square. This is the expression h square over 8 ml square, right? Okay, so you have to mention that quantum number which is directly proportional relation of energy, and that quantum number relation is directly. Okay, so in this, m is mass of particle, clear, and l is length of box. Okay, so h is Planck's constant and n is your principal quantum number here. Okay, so you can see energy is directly proportional to n square. Okay, so fourth option is your correct answer in this question. In the next question, in the following reaction, what type of polymer will form? Okay, so what will happen here? You have to simply look into the general structure, and so that you can tick your final option. Okay, final answer. So what will happen? You can see this is diol moiety. Okay, first of all, this is diol. Okay, so I'm showing you just one example, like this type of structure. Okay, and second, there is ester. Okay, so from this you can see it has ester functional group, okay, in the both side, and obviously there will be a formation of polyester, but I'm showing you one example, like okay, so you know that ester is formed from a reaction of alcohol plus acid. Okay, so what is happening here? This reaction is already started. Okay, in the first step this reaction is already started, and this is prepared from the reaction. This ester is prepared from the reaction of alcohols, several alcohols with acids, clear, with diacids, like this is diacid. Okay, and when alcohol will react with this acid, you will see ester, and now further there will be a formation of polyester by treating it with several molecules of dialcohols. Okay, diols. So like in this example, when this diol will react with this diacid, what will happen here? There will a release of water molecule. Okay, this OH negative and this H positive of alcohol, H positive of alcohols, right, and OH negative from acids. So there will be a release of several number of water molecules, and you will see so this type of polymer. Okay, so you can see in this case this is similar, C double bond O O R, the C double bond O O R, this is your R group. Okay, this is your R again, this is carbonyl moiety. Okay, now it will react in the second step again, okay, with the several R groups, and this react with several alcohol groups, diols, and there will be a formation of polyester. So in this, first option is your correct answer. So you have to look or focus on the functional moieties. Okay, functional groups, like it contain ester and alcohols. So first option is your correct answer in this question. In the next question, what is the relationship between canonical and molecular partition function? So canonical partition function is Q, and molecular partition function, this is canonical partition function, okay, and this is molecular partition function. Clear? And you have to tell them their relation, and where n is independent non-interacting particles and E is total energy of the system. Okay, so the relation between canonical and molecular partition function for independent non-interacting molecule is first option. Okay, so this is the relation. Okay, so actually the canonical partition function of the system. Okay, so this canonical partition function for entire system, so this Q depends on energy, temperature and number of particles. Okay, and if we'll talk about molecular partition function, this is for single particle, this is for system, this is for single particle in system. Okay, so canonical partition function is for the system, and Q, which is molecular partition function, is for a single particle in a system. Okay, and it actually it includes the translational, rotational, vibration and electronic states of the particle. Okay, so it is related, molecular partition is a relate function is related to translational, rotational, vibrational and electronic states of the system. Okay, so this is the relation between canonical and molecular partition function, and here you can see here is 1 over n factorial. Okay, so this factor is included for indistinguishability of particle. Indistinguishability of the particle, avoiding overcounting of configurations. Okay, so first option is correct answer. In this you have to tell them correct IUPAC name, and you can see this is amine. Okay, so this is amine structure, and you have to write or tell them correct IUPAC name according to alphabet order. So you can see this is substituted amine, this is primary amine R NH2. Okay, so this is your R group. Okay, so you have to give numbering from this chain, from this side. Okay, this is substituted amine. Okay, and in the option they are giving you 4 amines. Okay, so you can see in this there is on the third carbon there is methyl, only methyl, one substituent is on the chain. Okay, so 3 methyl pent, there are 5 carbons with a single bond, pentane amine. B option is correct answer. In the next question, which of the following radiations required for electronic excitation have highest energy? Okay, so if you look at the 4 options, in the first 2 options they are giving you microwave and radio waves, and they have, you know that they have very low energy. Okay, and in UV and IR both has higher energy. Okay, so obviously first 2 options are incorrect. Okay, and if you have to look into these, so infrared is related to vibrational change. in the molecule. Okay, in the energy levels, you will see change in vibration energy levels in the infrared, but you have to tell them about electronic excitations, change in electronic energy levels that happens in UV rays. So electronic excitations you will see with the UV rays, and so C, third option is your correct answer in this question. Next, which of the following is not true? Not true for non-ideal solutions. Okay, so first is non-ideal solutions obey Raoult law at all temperature and pressure. Okay, so first statement is not true actually. So you know that non-ideal solutions don't obey Raoult law at all temperature and pressure. Okay, so Raoult law actually the applicables to ideal solutions only, and where you can say solutions interactions between solute and solvent are similar to those in pure components. Okay, but in non-ideal solutions that interactions between solute and solvent is not same, and due to which you will see a deviations from Raoult law in the case of non-ideal solution. But in the first option they are giving you non-ideal solutions obey Raoult law, and that is totally incorrect. So first is not true for non-ideal solutions. Second is interactions between solute and solvents are different. This is correct option. Okay, um, this is true for non-ideal, but you have to mention not true as your final answer. So first option is okay. Then enthalpy of mixing is 0. Yeah, this option is also not true. Okay, and according to me in this question there are two answers, one is first and one is third. Okay, because there are different interactions between solute and solvent molecules in the case of non-ideal solutions, right, as we said. And if there are different interactions, obviously there is a some absorption or a release of heat in the system. So enthalpy of mixing is not 0. Okay, and they are saying enthalpy of mixing is 0 here, so that option is also not true for non-ideal solutions. Okay, so this, so enthalpy of mixing is not 0. Third option is also correct answer. Fourth is volume of mixing is not 0. Obviously, so volume of mixing is not 0 for non-ideal, meaning total volume of the solution is not simply the sum of volume of pure component because of different interactions between solute and solvent molecules. Okay, so first and third options both are correct. Both are not correct, sorry, so not true. Okay, for non-ideal solution, and overall you will tick first and third option as your correct answer. In the next question, which of the following statements are correct? Okay, so in this question first is in an ammonia solution dark red brown compound this having +4 oxidation state when 30, so overall when you will read it all four statements are correct. Okay, so when 30% hydrogen peroxide is added to alkaline solution of dichromate, so what will happen, a red brown tetra peroxo compound is formed, and in this, in the second option you can note in this chromium will get +5 oxidation state. Okay, and in the first option it is correct, in this chromium exhibit +4 oxidation state. Okay, all options, four options are correct. If you will read its data, all options are correct. So third option is correct, A, B, C, D options. In the next question, the maximum number of lines produced when electron jump from and so you have to mention incorrect statement. Okay, so maximum number of lines produced when electron jump from nth level to ground state is this. So yeah, generally, okay, in the line spectrum of hydrogen, if we want to find number of lines, this is the general formula we use. Okay, so n is the when electron jump from nth level to ground state. Okay, so this is general formula we use, and this is correct, a option, but you have to mention incorrect your answer. In the third option they are saying wavelength of spectral line from electronic transition is inversely proportional to difference of in energy level, obviously. Okay, so energy, you know that energy is equal to h nu, that is c over lambda, and at the end you will see inverse relation between lambda and energy. Yeah, so third option is option. The spectral lines corresponding to radiation emitted by an electron jumping from these orbits to second orbit belonging to Balmer series. So this is also correct. Okay, this is second series in the line spectrum of hydrogen atom. So this option is also correct. So incorrect option is second, which is just opposite to first statement. So second option is your correct answer. Next, what is IUPAC name for the following compound? So you can see in this case they are giving you O's. So this is generally they are mentioning esters, ethanoate. Okay, in the third option, and this is not ester. You know ester is C double bond O O R group. Okay, and this containing functional group this, which is anhydride functional group. Okay, so this is anhydride, so you have to choose one option from first, third, second and fourth. Okay, now this is ethanoic anhydride. Second option is correct because anhydride is generally formed from the two different acids. Okay, so this is ethanoic anhydride because ethanoic acid, you have to take two molecules of ethanoic acid. This is ethanoic acid, and after release of water molecule you will get this anhydride. Okay, and which is ethanoic anhydride. So because it is formed from two molecules of ethanoic acid, so this is ethanoic anhydride. Okay, so you have to choose these two carbons for ethanoic, and this is anhydride moiety, so ethanoic anhydride. Second option is correct. Okay, and in the case of butyric anhydride you need 4 carbon, but there are only 2 carbons in the continuity. Okay, so second option is correct answer. Next, 3-bromo 2,2,3 trimethyl so you can is allowed to react with sodium ethoxide in ethanol. Sodium ethoxide in ethanol. Okay, so when you will add sodium ethoxide in ethanol, in that case sodium ethoxide acts as a strong base that will abstract a proton from the system. Okay, now if you look into the structure, pentane, there are 5 carbons, right? In the second there are 2 methyl groups, 2,2 methyl, right? There are 2 carbons. In the third position there is also 1 methyl group, and they are also saying in the third there is bromo. Clear? So I already said sodium ethoxide acts as a base to remove proton. Yes, and there will be a removal of Br negative and hydrogen. It will abstract a proton on the transposition of this bromine, and this base will abstract this proton. These electrons will shift here, and there will be a removal of bromide anion. So ultimately at the end you will see here E2 mechanism. Okay, E2 elimination reaction, E2 mechanism, and you will see a double bond here, but at the end you will get, in the E2 mechanism, your final product will be trans. Okay, and that means you will see E alkene, and that is mentioned only in the case of fourth option. Okay, and so trans actually most stable transalkene due to its anti periplanar arrangement of a hydrogen and bromine atom during elimination process. So fourth option is correct answer. In the next question, rate of reaction depends on the nature of participating substances. Which of the following is not a factor that affects reaction rate? Okay, so there are four options. First is catalysts. Clear? So you know that catalysts speed up the reaction rate by lowering the activation energy that is required for the reaction. So catalyst play a role. So first option is incorrect here. Second is temperature. So high temperature, so increasing the temperature generally increases the reaction rate by providing more kinetic energy to the reactants. Clear? So high temperature also play a crucial role. Third is size of reactants. So you know that size or surface area of reactants can affect the reaction rate, particularly for heterogeneous reactions where reactants are in different phases. So first, second and third options, these three options are incorrect. It involves or affects reaction rate. Okay, now fourth option is spectator ions, which is our correct answer. Spectator ions not a factor that affect reaction rate. Okay, because spectator ions don't participate in reaction and therefore don't affect the reaction rate. They remain unchanged and simply balance the charge in the reaction system. So spectator ions, you can note, remain unchanged and balance the charge in a reaction mixture. Clear? So fourth option is your correct answer here. In the last option, last question, match the water pollutants and their sources. So B option is correct answer here. You can see obviously acids, if we talk about acids, and these are water pollutants and their source is directly mine effluents. Okay, and oxygen demanding waste generated from paper mills and food processing units. Okay, and that are plant nutrients that are obtained from detergents or agriculture sources. Okay, and last option is polychlorinated biphenyls, and that is directly obtained from waste ash and toxic refuse. So B option is correct. Okay, remaining questions I will try to cover in one more video. Okay, and if you like the video, share it with your friends and subscribe the channel. And if you have any query, any doubt in the questions, and then you can write in comment section, I will respond. Thank you very much.